Hi, it's Bentley's mom. I'm going to do some of the homework, independent practice 4, 6, 7, 8, and 10, and the hot problems 11 and 13. So the first one, I already have this written up here. Do you want to say hi, Bentley? Hi. So you're saying hi to you guys? Here is, go to page 788. This is number 10 from the independent practice, and they have this chart here. They give you the three-dimensional figure, and then they're asking you how many rectangular faces it has and how many triangular faces does it have. And these two are two-dimensional because they're just the actual faces. So in a rectangular prism, which looks like this, okay, the question is how many rectangular faces does this have? So 1, 2, front, back, side, side, top, bottom. So there are 6 rectangular faces, and there aren't any triangular faces on this one. Okay, on a triangular prism, you're going to have a triangle and a triangle as the bases. So there's 2 triangular faces. And then connecting those, you're going to have 3 rectangles off of that. So there's another 3 rectangular faces. This pyramid is where it comes to a point. So rectangular, okay, which is squares a rectangle, there's going to be 1 here, and then the triangular faces, there's 4 triangles coming off of that to a point. So that's this one. And then a triangular pyramid, instead of this being a rectangle, this is going to be a triangle. So you're going to have 1 as the base, okay, but then you're going to have 3 coming off the sides. So you have 1 and then plus the 3, which will give you 4 total, okay, and there's no rectangular faces there. Okay, so prisms again are like this. They have 2 bases. Pyramids come to a point, and then you, as soon as you identify the object, then you can find the area. Okay, so that was the independent, I think, number 10. So let's do 4 and 6 real quick. Okay, number 4. Says, okay, so let's first look at what kind of object it is, and it comes to a point, so it's a pyramid, and I look at the base, and the base is a square. Okay, so I'm going to find the area of the base, and it's 5 by 5, so 5 times 5 is 25. So there's my base area, and then off of that, there's going to be 4 triangles. And the slant height, the reason it's called slant height is because see in a pyramid how these triangles come in and they're kind of slanted, they slant in. So the height of this triangle is actually called the slant height because they're slanted. The regular height would be if something's perpendicular and it's not slanted. So you take the slant height here, it looks like it's 8.2, and then this is 5. So you do 1/2 base times height. And you get 20.5. And then how many of these are off here? There's 4 sides. So we're going to take 20.5 and multiply it by 4. And we get 82. Okay, and I would suggest if you know how to do long multiplication, use a calculator. But if you're still struggling, make sure you practice. So this lesson's not necessarily on long multiplication, but if you don't know how to do it, please practice it because you do need to know how to do this by hand without a calculator. Okay, but if you know how to do it and you can use a calculator, then it just might be a little bit faster. So we have the base area, which is 25, plus all the lateral faces, which is 82, and you add those together, and we get 107. It's going to be squared feet. Okay, so that's number 4. Now number 6, if we look at that shape, 6 is a pyramid because it comes to a point, and we look at the bottom, and it is a triangle. So this is a triangular pyramid, and this is 3, and this is 2.6. So we're going to have 1/2 times base times height, and we get 3.9. That's our base area. Okay, and then off of that, we're going to have 3 triangles, and those are called the lateral faces. We have 1/2 times 3 times 6. So this is 3 and that is 6. And you could either do 1/2 of 6, which is 3. 3 times 3 is 9. You can also do 3 times 6 is 18. Half of 18 is 9. Again, multiplication has a commutative property, so if you want to switch them around, it doesn't matter the order you do multiplication. So you get 9, and there's 3 of those. So 9 times 3 is 27. So then you're going to take the base area, which is 3.9, and all 3 lateral faces, which is 27, and we're going to add that together, and we get 30.9, and it's in inches, so it's going to be inches squared, or squared inches. Okay, that's number 6. Okay, let's do number 7 and 8. Okay, number 7 says, a tea bag is shaped like a square pyramid. Okay, so that means the base, pyramids are always named by their base, so that's going to be a square. And the base is 4 centimeters on each side. So our base area is going to be 4 times 4, which is 16, okay, of the tea bag. And then it says the slant height is 4.5. So of this, the slant height right here is 4.5, and this is 4. So we're going to do 1/2 times base times the slant height. 1/2 of 4 is 2. 2 times 4.5 is 9. And because this is a square, there's going to be 4 different triangles. So we're going to take 9 and times it by 4, and we get 36. So I'm going to take the area of my base, which is 16, and then all the faces, which is 36, and I get 52, and it is centimeters squared. Okay, that's 7. Okay, now we're going to do number 8. Okay, and then 8 says, an earring design is shaped like a triangular pyramid. So the base is going to be a triangle. And it says all the faces are equilateral triangles. So all of the faces, including the base, are all the same. So, and it says the side lengths are 14, and the slant height is 12.1. Okay, so we're going to find the area of this, which is 1/2, times the base, which is 14, times 12.1. 1/2 of 14 is 7, and 7 times 12.1 is 84.7. But it said all the faces are the same. So you're going to have one base and 3 lateral faces. So total there's 4. So we're going to take this and multiply it by 4. Okay, on the other ones you had to do the base separately, and then you would multiply this by 3. But because it said they're all the same, we're going to multiply it by 4. And we get 338.8 millimeters squared. Okay, and then we did the chart on the top of page 788. So now let's do the hot problems. Okay, 11 says, find the error. It says there's a square pyramid, okay, and it shows Pilar's finding the surface area of the pyramid shown. Find her mistake and correct it. So she wrote 25 plus 25 plus 4 times 21.25 equals 135. So what this was, it had a base here. This is 5 and this is 5. So the base would be 5 times 5, which is 25. And then there's 4 lateral faces, and then that was the area of the lateral faces. So this is actually correct too. But what she did was she added in a second base. So that second base would mean it would be a prism, not a pyramid. So there would have to be a base here and a base here. So this is the incorrect part. Okay, so it would just be this and this. So that was her mistake right there. Okay, that's number 11. And then the last one, number 13, it says justify your conclusion. It said, it's a hot problem. Suppose you could climb to the top of Pyramid Arena in Memphis, Tennessee. Which path would be shorter? Climbing a lateral edge, which would be this, or the slant height. So the slant height is this. Remember, because if it's a pyramid, the triangles are kind of slanted in. And so the height of that, this is called the slant height right here. And this is lateral, means sides. That's the edge. So that would be called a lateral edge. So what's shorter? So remember, this is a 90-degree angle with the slant height and the base. And if you look at this triangle right here, okay, this is actually the hypotenuse. And the hypotenuse is always the longest leg of a right triangle. I'm just looking at this right here. So this lateral edge is actually longer than this slant height right here. So the quickest way would be to take the slant height. Okay? And that's it. Thanks.